Want of factor. Want of factor is the factor introduced in the colligative properties. We know colligative properties are used to calculate the molar mass of the compounds. But we know some of the compounds, ionic compounds, gets dissociate in the solution. Some of the compounds gets associate in the solution, and some compounds neither associate nor dissociate in the solution. The compounds which associate or dissociate in the solution shows different answers of the molar mass as we calculated. That means we get some wrong molar masses of some compounds which associate or dissociate by using colligative properties. To correct these errors, we introduce a topic that is called want-of factor. Want-of factor is defined as the ratio of observed colligative property to the normal colligative property. It is also defined as the normal molecular mass divided by the observed molar mass. We know we have two types of colligative properties. One side of the colligative property is observable. Another side of the colligative property is calculated. So the ratio of observed colligative property divided by normal colligative property is called want-of factor. The compounds which shows normal behavior in the solution, for these compounds we take want-of factor I equal to 1. For the compounds which undergoes dissociation, we take want-of factor greater than 1. For the compounds which undergoes association in the solution, the want-of factor is always less than 1. Want-of factor is multiplied on the right hand side of all the four colligative properties to correct the error in the molar mass. Let us check out the mathematical formula of all the four colligative properties in terms of want-of factor. The first colligative property, relative lowering in vapor pressure. Second, elevation in boiling point. Third, depression in freezing point. Fourth, osmotic pressure. We multiply want-of factor on the right hand side of these colligative properties mathematical relations. Let us check out how we calculate the value of want-of factor for different compounds. To calculate want-of factor, we need degree of association or degree of dissociation. We know about the degree, we have already studied in the 11th class. The degree of association is defined as number of moles of solute associated divided by total number of moles of the solute. Second, degree of dissociation. Number of moles of solute dissociated divided by total number of moles of solute. The degree of association or dissociation is denoted by alpha. Let us check out how the alpha degree of dissociation or association is related to the want-of factor. First, in terms of association. Let us consider a chemical reaction having n molecules of compound A which associate to form A whole n. That means n molecules associate with each other and forms one molecule having n atoms of A. Let alpha be the degree of association. Then we can say that number of associated moles equal to alpha divided by n. Number of unassociated moles equal to 1 minus alpha. Hence, total number of moles after association, that is equal to 1 minus alpha plus alpha by n. Now put the value in the mathematical formula of want-of factor. Then finally we get alpha equal to I minus 1 divided by 1 by n minus 1. In the above reaction, A whole n, one molecule containing n atoms are formed. Then the value of n equal to n. If we take the compound of acetic acid in benzene, then two molecule of acetic acid associates, then n equal to 2. Similarly, benzoic acid also associate with two molecules, there also the n equal to 2. Now let us check out the relation between degree of dissociation and Van 't Hoff factor I. Now let us check out the chemical reaction. N molecules of A dissociated and forms n molecule of product. Then number of ions formed equal to n into alpha. Number of moles undissociated 1 minus alpha. Total number of moles after dissociation 1 minus alpha plus alpha into n. Now put the value in the mathematical formula of Van 't Hoff factor. Now we find the formula alpha equal to I minus 1 divided by n minus 1. Here n is the number of moles which are produced in the product. The value of n can be determined in terms of dissociation, like sodium chloride NaCl. NaCl dissociate into Na positive and Cl negative. 1 sodium cation, 1 chlorine anion. Total number of ions equal to 2, hence n equal to 2. If we take the example of aluminium chloride completely dissociate into Al3 positive 1 cation plus 3 Cl negative 3 anions. Therefore, total ions are 4. Hence, the value of n is 4. Also, find out the value of n for these examples in terms of association or dissociation. You can also try the numericals which are given in the video for practice.